Reviewing that worksheet, which is Chapter 10, Form 2C, correct? All right. And this is 13 to 16. So, number 13. Oh, I hate... See that little line goes through there? I hate that. Oops. There we go. All right, 13. Find angle ACE. ACE. Tell you what I'm going to do. Let's plop this up to here so I can see it. And then 14 is ADB. 15 is AFE. Angle AFE. And 16 is EHD. Oops. Angle EHD. D. Okay. Alright, let's just start with 13, might as well. And let's pink. Okay. Alright, ACE. Where's ACE? A. Where's C? C, E, angle. So we're finding this angle right there. Okay, well, what do we have here? It looks like we got two secants, right, that intersect outside the circle. Outside the circle. They intersect out. So there's a secant here. Let's see. Okay, let's take a look at this. To find this angle right here, if it's the angle that intersects outside the circle, it's the difference of the two arcs that it cuts off. Remember that? So watch, it's this arc right here. Oh, let's try this again. It's this arc right here minus this arc right there. And then take half of it. Problem is, we've got to find that arc. It's not that big of a deal, though. It's pretty easy, isn't it? Watch. If this, see this thing right here? That's the diameter. That's 70, and the rest of it is AE. So how do we do that? 180 minus 70, which is 110. So that's 110 right there. This arc right here is 48. Do you see how that... Do you see how these two things, these two secants, cut off those two arcs right there? And you divide it by 2. So it's 110 minus 48 divided by 2. So what is that? That's, I don't know. What's 110 minus 48? 62, thank you. 62 divided by 2, which is 31. So that's 31 degrees. All right? So that's one thing that you have to know. It cuts off those two arcs. You subtract them, right? And then you divide them by 2, and that's what that outside angle equals. All right, so that's that one. ADB is next. Go ahead. Well, you'll have enough information to figure it out. Let's see. Because, look, this is a diameter, right? So this is half of the circle. So if this is 70, this is 180 minus the 70. Okay? Any other questions on that one before we move on? All right, ADB. Let's find ADB. There's A, there's D, there's B. So it's this angle right there. Oops, daisy. That's because I did the fill thing and I meant to do this thing right there. All right, ADB, which is that angle right there. Well, this is an inscribed angle, isn't it? Because they're two chords, okay, that intersect right on the circle. So it's an inscribed angle, which is just what? It's half of the arc that it cuts off. What arc does that angle cut off? ADB. It cuts off this arc right here, which is AB. And they already told you what AB was. It's 82. So how do we find this angle right here? That's right. It's just 82 divided by 2, which is 41 degrees. And that's that angle right there. Let's get rid of the arrow and we'll put the angle in here. 41. Okay, can you read that? It's kind of skinny. Yeah, you have to know. Yeah. Yep.
Wait.
All right. Let's keep going. What?
Are we going to have questions with
Don't know. I don't know how they come out. I kind of doubt it. I usually don't do that on a test. But I don't know. It's already made up, and it's hard to tell just by looking. It doesn't look like you'll have to know how to do the quadratic formula. No, I said we weren't. You got to listen. I already said that. So we're done with that one. AFE. AFE. So that's this one up here. Let's go to a different color. What haven't we used yet? Orange. Okay. So AFE. So this is a tangent, isn't it? It's tangent right here and it's tangent right here. And it has two arcs that it cuts off, right? But look at what they are. It's this big one all the way around to here. Okay? And it's got this one right here. And that's not too hard. That's not too bad, is it? So look, if this is 110, what's this? What's this big old arc right here? ABE. Okay, it's 250. And I'll just put that in orange. So that's 250 degrees. How do we find this arc right here? Good. Oops. One too big. So watch, you take, it's the difference of the two arcs. It's the same rule as this one right here. It's the same exact rule, except these were secants, this is the tangent, but it's the same rule. You take both arcs that are cut off, and the tangent cuts off this arc right here and this arc right here. It's the whole circle, right? But it's what? It's 250. And how did we get 250? Well, this was 110. We already knew that was 110 from earlier, didn't we? So 360 minus 110 is that whole thing. So what do we do now? We take that big arc right there, which is 250, minus this smaller arc, which is 110, and then we divide it by 2. 250 minus 110 is what? 140?
Yeah, divided by 2.
Divided by 2 is 70 degrees. So that angle right there is 70 degrees. All right. All right, let's look at the next one. EHD. What color haven't we used?
Purple.
I haven't used red. Let's use red. I said red. This looks too close to purple, this one. EHD. Where's E? Right here. EHD. Okay. Well, look what we have. We've got... We have a chord and a diameter, correct? Let's find, I tell you what, let's find this right here. Let's find this. Can we find this angle? This arc from D to some unknown, we'll call that X. From D to X. So 82, 48, take that away from 180. Somebody do that for me real quick. It's 50. 180 minus 82 minus 48. Good, it's 50. I just found this arc. I don't know if you need it or not. I just was interested in finding it because this is sitting there. I don't know what it is, okay? And who knows? I might need it. So that's 82. That's 48. This is 50 because they all add up to 180. All right? Correct. Yep, they should. Correct. Let me think for a second. EHD. So it's this angle right here is what we're trying to find, isn't it? See, the reason I did this, I was thinking that, okay, if this was 70, then this would be a right angle, wouldn't it? Because if it's perpendicular, because if it bisects the arc, then it means it's perpendicular to that diameter. But I guess it's not 90 degrees, is it? I'm trying to think. I haven't figured it out yet. I gotta think. Well, they probably already know I'm stupid, but I'll pause it anyway. All right, yeah, let's do that. That's a good job. Watch. So if we find this angle, it's the same as this one right here. So look at the triangle. Look at triangle AHC. Everybody see that one? Right there. So if this is 31, we should be able to figure out this angle right here, shouldn't we? Because it comes to here, it comes to here. It's an inscribed angle. So look, it's this arc right here, which is what? 98. So if this arc is 98, this is divided by 2, and 98, what's that? 49. So that's 49. And now look what we have. We got, see this big triangle, AHC? We got 49, we got 31, and then you just take those two away from 180. Somebody do that for me, please. 180 minus 49 minus 31. What's that? Oh, it's 100, because that's just 80, right? So that would be 100. How did we get what? The 49? Because this is an inscribed angle. Angle A is an inscribed angle, and it comes to D, and it comes to B. So this arc, BD, is 50 and 48, which is 98. See that? So this arc right there is 98. This is half of 98, which is 49. So if that's 49 and that's 31, this has to be 100, because they add up to 80, and that's 100, that's 100. So 100 is your answer. Okay? Good. Kind of like a little puzzle, wasn't it?
Yeah, number 6 was like, I asked you about number 6, but no, I think I did this one.
Number 6. All right. All right. Let's take a look. What we got here? All right. You got a radius coming from here, and then you have a yeah. 3 is this little itsy bitsy part, right? So 3 is just, oops. Let's try this again. I gotta click off. Ah, come on. I don't want that yellow. I want that white. There we go. Now I can change my color. So this little bit right here is 3. And then it says PQ is 18, right? PQ is 18. Yeah, because it says find the distance. Listen to this. It says find the... Shh. This is subtle, but it's an important thing. Okay, I don't want to assume that this thing is split in half. Okay, I don't want to assume it. I want to know why. Because look what it says. It says find the distance from O, which is right here, to PQ. What does it mean to find the distance from a point to a line? It's the what? It's the perpendicular distance, isn't it? If I have a point in a line, what's the distance? It's perpendicular, right? So that means this has to be perpendicular. How did I get that? Because it says find the distance from this point to this line segment. So it has to be perpendicular. You got it? Now, what did we learn? We learned something about a radius being perpendicular to a chord. If it's perpendicular to a chord, what does it do to that chord and what does it do to the arc? It bisects both of them, doesn't it? So if PQ is 18, then what is it from P to this point right here? It's got to be 9. Now, you probably could have got away with just guessing it, but as a teacher, I have to show you exactly why that's 9, all right? And what are we trying to find? We're trying to find that distance from here to here. We'll just call that x. Is that all right? That's the distance from O to that point right there. So what do you think we need in here now? Probably need this, don't we? Okay. Now, here's a little bit of a problem. No, there's no problem, is there?
Because
oh, yeah, you need this. Right. You need OP. Now, OP is the radius of the circle, isn't it?
Yep.
X plus 3 is the radius of that circle. So that's a little bit, that's where it got a little bit confusing, okay? So OP or PO is X plus 3 because that's the radius as well, isn't it? From O to whatever that thing is right there. Now you can do Pythagorean Theorem, but you're going to get a quadratic. Let's do it very quickly. Again, I don't know if you have a quadratic on the test. I kind of doubt it, but let's do this anyway. It's, watch, x squared plus what? 9 squared equals what? X plus 3 squared. Yeah, you got a FOIL. Well, actually, the x squareds cancel out, don't they? And then it's pretty easy. So watch. So when you have an x squared, watch. This is a quadratic right here. So it's going to be, you got to FOIL it. X plus 3 times x plus 3. So that would be x squared plus 6x plus 9. Now, this is kind of, see, this right here is a quadratic. When you have something written ax squared plus bx plus c, that's a quadratic. But the nice thing about this is that the x squareds cancel each other out. Oops, what am I doing? All right, so watch. That, you subtract them from both sides, right? This is 81. So let's do this. Let's subtract a 9 from this. So 81 minus 9 is what? 72. And that equals 6x divided by 6, and that would be 12. All right? No, because that's x. That's x, and that's what you want to find, the distance from O to that line segment O.
Can you just read number 10 really quickly and then tell us if we have to do something like that on this? I don't think we
number
do,
10
but
was
I don't
so
remember.
hard. I couldn't
Triangle is
even figure it out.
circumscribed. Now let's draw it. You need to know what it means for a triangle. I don't know if they have that on, if I have that on the
I
test.
don't think they show. It was a really hard program.
Nah, I don't have a triangle circumscribed on a No, there's no clock. I read everything else. I read everything to you that's going to be on the test. there's no inscribed triangle. There is an inscribed quadrilateral, but I didn't put an inscribed triangle on there. All right, but just for the sake of doing this, watch. What's an inscribed triangle? Actually, what did we do before? What was on the quiz? It was inscribed in a semicircle, right? And that's not going to be on there either, but don't worry about that. We won't do that just because we don't want to waste our time. What else? We got about 2 minutes left. Number 9. That won't be on the test. Don't worry about number 9. 17. Right.
Oh, number 9. Didn't you just do the slope
Number 17 is a little more difficult than I would have on the test. Really, the one for the equation of a line on the test is just super easy. I mean, it's real basic. There's really not a lot of thought. You just have to know what the numbers represent, right? Because I give you an equation, you tell me what the center and radius is. I give you a center and radius, you tell me what the equation is. I couldn't make that any easier. 10? Don't worry about the bonus. Nah, number 10 is not going to be on the test, so we'll just stick with, I just want to stick with stuff that you'll probably see on the test. You're going to turn this in tomorrow. Turn this in tomorrow.
And the test is tomorrow?
Yeah, number 12 I can do real quick for you.
Yeah, the test is tomorrow, bro.
I don't know.
What study hall do we have today? Oh, we have a kitty.
Come in the same room as me,
Okay.
If you want to stick, if you can stick around for number 12, feel free. That's supposed to hit right there. You get the idea, right? That's 4, that's 3, and that's x. Okay, this is the one where this is the secant. So it's the outside part times the whole thing. Right? The outside times the whole entire secant equals the tangent, and it comes to here, right? And that's just 4 squared, and then you just do your math and you solve for x. Right? It's the outside times the whole thing equals the tangent squared.
What was the answer for that?
I don't. What number was that? 12. 7 over 3. What's that?
Can you look at 9 real quick? Do you just do the slope formula?
Number 9. That's not going to be on the test, but yeah, you'll need to know the slope for that. You're welcome.